Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it. This is chapter 4.2, which is on trig functions and the unit circle. All right. So now, here first let's do something with trig. And here, the root word for trigonometry is triangle. All right. So let's do something with triangles here. Let's consider that we had the following right triangle. All right, so we have this right triangle where this angle over here, we're going to call this angle theta. Respective to this angle, we've got this side over here on the bottom being the adjacent side. This side over here, this leg over here, we have that being the opposite side. And over here, across the 90-degree angle, we call that the hypotenuse. All right, so that is a right triangle in general and how we're going to be thinking of the sides. Now, there are 6 possible ratios. All right, we can do the opposite over the hypotenuse, and we can do its reciprocal, the hypotenuse over opposite. We can have the adjacent over the hypotenuse. We can also write the reciprocal of this being the hypotenuse over adjacent. And we can have the opposite over the adjacent and its reciprocal. So we can have the opposite over the adjacent and its reciprocal, the adjacent over the opposite. Now, all of this is with respect to this angle theta. We have names for every single one of these ratios. This first ratio is called sine theta. The second ratio over here, so opposite over hypotenuse, that was sine. Adjacent over hypotenuse is cosine theta, and opposite over adjacent is tan theta. Similarly over here, the reciprocals also have names. The reciprocal of sine, excuse me, the reciprocal of sine is cosecant, and again, that was the reciprocal of sine. We also have the reciprocal of cosine, which is called secant, and again, that was the reciprocal of cosine. And we also have cotangent, which is the reciprocal of tangent. So that would be 1 over tangent. So those are the 6 possible ratios, all right? And each one of these ratios is what we like to call the trigonometric functions, all right? Now, the most common way to remember this is remembering this column being SOHCAHTOA, right, where we have sine is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Let's make a quick note here. Note. If I take sine theta over cosine theta, what I end up with here is, well, sine was the opposite over the hypotenuse over cosine, which was the adjacent over the hypotenuse. So now we've got a fraction divided by another fraction. We know that when we divide by a fraction, it's the same thing as just multiplying by the reciprocal. So I have hypotenuse over adjacent. And in here, the hypotenuse cancels out, which we end up with opposite over adjacent, which if you'll notice here, that's just tan theta. So in here, what we found is that tan theta is equal to sine theta over cosine theta. It can also be shown that cotangent theta would be cosine theta over sine theta. All right, you can also think of it as, remember, cotangent was a reciprocal, so the reciprocal of sine over cosine would be cosine over sine. All right, now that was just the definition of all these 6 trig functions. Now let's talk about circles. So let's start talking about the unit circle. So first, consider a circle of radius 1. So consider a circle of radius 1. So essentially what we're saying here is this is r is equal to 0. Excuse me, r is equal to 1. And not just that, we're considering a circle. If you recall, a circle would be something like this if it was centered at the origin. All right. So what we're going to do here is let's draw a circle. So we're going to have x squared plus y squared is equal to 1, right? Because our radius is 1 and 1 squared is just 1. And we end up with the following circle. All right. Now, in here with the circle, and perhaps I'll make it a little bit smaller. Yeah, there we go. With the circle, I'm going to put it on the coordinate axis. All right. So here is the y-axis, and here is the x-axis. Let's make this y-axis a little bit bigger. All right. And that's pretty centered. All right, good. Now, in this unit circle, well, we know the radius is 1, so we can already say some stuff about this. We can say, for example, that this point right here is a point 1, 0, and this point up here is a point 0, 1, because it's a radius 1, right, in this circle. This point right here would be negative 1, 0, and this one down here would be 0, negative 1. All right, now let me shift this over so I can say something else about this. If we consider the point, so let the point P be equal to just some xy coordinate at the angle theta. All right, so what is that going to do? Well, what that's going to do is we're going to have a point here somewhere. It's our point P, where its coordinate is x comma y. And this is going to create a triangle here. All right, this triangle, where this right here is our angle theta. All right, so at angle theta, we've got the point xy, the point P at xy right on the circle itself. Now, in here, well, what does this really tell us? This point P and xy tells us that this triangle, well, this value is x, and this value is y. All right, so from this triangle right here, remember this radius over here is equal to 1, because that is the radius of the circle. So that's r is equal to 1. Let's write that better. All right, so the hypotenuse there is just 1, because that is the radius. All right, now, what does this actually tell us? Well, if I look at sine theta here, sine theta, if you recall, was opposite over hypotenuse. So from this angle, the opposite is y, the hypotenuse is just 1, so sine ends up being just y. For cosine theta is adjacent to the hypotenuse, so the adjacent is x, the hypotenuse is 1, so I get just x. Similarly, I would say that cosecant theta will be the reciprocal of this, 1 over y, and secant theta will be the reciprocal of cosine, which is 1 over x. The other thing that we know now is that tan theta was sine over cosine, So sine over cosine would be y over x, and cotangent theta will be the reciprocal of tangent, which is x over y. All right. So if we have any point on the unit circle itself, we can figure out, based on this angle, what the coordinates would be off of this, or what would the value of the trig functions be off of this. So that's where the unit circle comes in. All right, and I will make a note here for some of these. In here, y cannot be equal to 0. In here, x cannot be equal to 0. In this one, y cannot be equal to 0, and in this one, x cannot be equal to 0. And that's because our denominators can never be 0. All right. So now let's actually draw the full unit circle. And once again, let's draw a big circle here. And we're going to put coordinate axes on these. So here is my y-axis, and here is my x-axis. And that is pretty centered. Let's just make this a little bit bigger. All right. Now, with the unit circle, what we need to talk about is all the angles that we care about here. All right. And the angles that we cared about, we've already discussed in a previous lecture. Essentially, they're going to be, we're going to split this up into a whole bunch of different angles, and I will show you what they are in a second. First, let me just set this up. Oh, that is awful. Let's try that again. The one that's going through the center there. Ooh. There we go. A couple of more of these, and then we can start filling this out. All right, so here's our unit circle with all of these divisions. Essentially, we're going to be looking at 3 angles on each quadrant. Now, this is how we build the unit circle. All right, first, let's talk about all the different angles that we care about here. We know this angle over here, because remember, in an angle in standard position starts here. We know this angle to be 0. Theta there is equal to 0. And the next one, well, actually up here, we know that to be pi over 2. So we'll do the easy angles first. This angle over here is pi. Over here is 3 pi over 2. And all the way over here, a full rotation is 2 pi, right? The next thing that we're going to be considering here is all these coordinates in the first quadrant, all right? Now, in these coordinates, the angles that we care about, or what they are pi over 6, pi over 4, and pi over 3, all right? We need to memorize those angles. Now, in the second quadrant, and the rest of the quadrants here, we're going to be using pretty much the same things here, but our numerators are going to be different, all right? In the second quadrant, all of our numerators are going to be the denominator minus 1. So what do I mean here? Well, this one right here is going to correspond to this one. This one's going to correspond to that, and this is going to correspond to that. But we're going to say this first one up here is going to be something pi over 3. But the numerator is to be the denominator minus 1, so it's 2 pi over 3. Similarly, this one corresponds to this height, so this is something pi over 4, but the numerator is 1 less than the denominator, so it is 3. And finally, over here, we're going to get 5 pi over 6 by the same reasoning. Now, in the next quadrant, we're going to start with a similar reasoning, lining these up this way, essentially mirror image vertically there. And in the third quadrant over here, all the numerators are the denominator plus 1. So first, well, this is going to be something pi over 6, and is the denominator plus 1, so 7. This is something pi over 4, right? And the denominator, and the numerator is a denominator plus 1, so 5 pi over 4. And this one over here is something pi over 3, and the numerator would be 4. Right, and again, that's because they match this way. In the fourth quadrant, we're going to say all the numerators are twice the denominator minus 1. And we're going to pair them up in the same exact way, whether we go this way or this way. They still match up in the same way. This one right here is something pi over 3, something pi over 4, and something pi over 6. So when we go to fill out our angles, this is something pi over 3, and when the something is twice the denominator minus 1, so 5. This one over here is something pi over 4, twice the denominator minus 1, it's 7. This one, something pi over 6, twice the denominator minus 1, it's 11. So far we filled out all the angles of the unit circle. The next thing we need to figure out is all the coordinates of this unit circle. Now we already know some of these coordinates, right? Because we were discussing them over here. The unit circle was where we had radius 1, so we know these coordinates. So let's go ahead and write some of these coordinates in. The first one here, at theta being equal to 0, the coordinate is 1, 0. Up here for pi over 2, the coordinate was 0, 1. For pi, the coordinate was negative 1, 0. And for 3 pi over 2, the coordinate was 0, negative 1. All right. Now let's look at the rest of these. First, with these angles right here in the first quadrant. In this first quadrant, we have, or we can write the following. We can say every single coordinate here is a fraction. Every single one of those. But not only is it a fraction, it is a fraction over 2. So every single one of these has a 2 in the denominator. Now, the next two steps are as easy as counting to 3, as well as counting backwards from 3. Down here, down the x values, we're going to count to 3. And we're going to say 1, 2, 3. On the y values, we're going to count down from 3. 3, 2, 1. The next thing we're going to do is we're going to put square roots on all the numerators. So square root of 3, square root of 2, square root of 1. But the square root of 1 is just 1, so we don't really need to put it on there. And then over here, square root of 3, square root of 2, square root of 1. But we know the square root of 1 is just 1, so we don't need to put it on there. And there we go. We've got the entire first quadrant already figured out. The next thing we're going to do here is we're going to say, well, all of these coordinates were in the form of x comma y, right? Well, originally. But if you think about how all the coordinates happen in the second quadrant, the x values are negative and the y values are all positive. Similarly, in the third quadrant, the x values are negative and the y values are also negative. In the fourth quadrant, the x values are positive and the y values are negative. And we already know in the first quadrant, they're all positive, all right? All the coordinates. So now it's just a matter of matching things up. This one that matches up with 2 pi over 3, I'm going to take the same coordinate, but I'm going to make the x value negative. So I'm going to say this is going to be negative 1/2, comma, radical 3 over 2. For 3 pi over 4, might match it up with that one, make the x value negative. So negative radical 2 over 2, comma, positive radical 2 over 2. For 5 pi over 6, same idea, match it up with that one, make the x value negative, so negative radical 3 over 2, comma, positive 1/2. Now, in this third quadrant, everything, both coordinates have to be negative. So I match them up this way again, in the same exact way that we've been matching things up. And I'm going to say, well, the coordinates now are going to be negative radical 3 over 2 comma negative 1/2 for 7 pi over 6. Negative radical 2 over 2 comma negative radical 2 over 2 for 5 pi over 4. And negative 1/2 comma negative radical 3 over 2 at 4 pi over 3. All right. And lastly, for our fourth quadrant, well, whether we line them up this way or this way, we still end up with the following result. Here for 5 pi over 3, lining up this way, it needs to be the x value is positive, so positive 1/2. The y value stays negative here. For 7 pi over 4, the x value is positive, so we have radical 2 over 2, and the y value is negative, so negative radical 2 over 2. And finally, this coordinate up here is going to be at positive radical 3 over 2 comma negative 1/2. One last thing I want to say about this unit circle. Well, actually there's a couple of points still. But one of the other things that I want to say about this unit circle is, what do all these represent? Well, if you recall this statement over here, we had that sine theta is equal to y when we had the unit circle here, right? So the y value is sine. So we have to keep in mind here that each of these coordinates, because they're in the form of x comma y, they're really in the form of cosine theta comma sine theta. And again, that's from this over here. All right. So it's the cosine theta comma sine theta. So always think of them this way. And what does that mean? Well, that means that, for example, if I go to 2 pi over 3 and I said, well, what's cosine of 2 pi over 3? Cosine of 2 pi over 3 is the x value of negative 1/2. What if I asked about sine? Well, sine of 2 pi over 3 would be the y value, radical 3 over 2. One other thing to keep in mind every time you're looking at the unit circle is this chart right here. All right. In here, a lot of people remember this as all students take calculus. All right. But what this is really saying is, where is each trigonometric function positive? In the first quadrant, all of them are positive. Right? All the trig functions are positive. In the second quadrant, sine is positive. All right? Sine is positive, but also it's reciprocal, cosecant. In the third quadrant, tangent is positive, but also it's reciprocal, cotangent. And in the fourth quadrant, cosine is positive, but also it's reciprocal, secant. All right? So that tells us how to keep everything here in mind as far as which trig functions are going to be positive or negative in which quadrants. All right, so, and again, for each one of these, we're talking about this being theta, right? Now, notice that all of my angles here were positive angles, all right? We can actually go the other way and talk about negative angles. And what that would do is, this first one over here would be negative pi over 6. This next one over here would be negative pi over 4. This one would be negative pi over 3. So essentially, these angles, but the negative version. This would be negative pi over 2. This would be negative 2 pi over 3, so on and so forth. Negative 3 pi over 4, negative 5 pi over 6, negative pi. Negative 7 pi over 6, negative 5 pi over 4, negative 4 pi over 3, negative 3 pi over 2, negative 5 pi over 3, negative 7 pi over 4, and finally negative 11 pi over 6. So that's if we were to have negative angles. And lastly over here, negative 2 pi. Here is still the same there, right? So it's important to keep those in mind, that if we measure the angle going the other way, we can still have a lot of information out of this unit circle. All right, so let's get some practice on some examples. So let's see. Now, I do want to be able to reference the unit circle. So there it is. We're going to be able to still look at the unit circle there. All right. Now, let's get some examples in right now. Let's say that the instructions were find. Oh, let's not write in green anymore. Find the 6 trig function values of each theta. So let's start easy. Let's say that I had theta being pi over 2. So what I'm saying here is, what I'm really asking here is, what is sine of pi over 2? What is cosine of pi over 2? What is tangent of pi over 2? What is the reciprocals of these? Cosecant of pi over 2. What is secant of pi over 2? And what is cotangent of pi over 2? And, well, in order to do that, we're going to take a look at our unit circle over here. All right. So when I go to pi over 2, well, here's pi over 2. All right. If I go to the angle of pi over 2, well, what was sine? Sine was the y value. So the y value is 1. So we're going to say here the sine of pi over 2 is 1. Similarly, if we stay looking at that coordinate right there, cosine is the x value, right? So the x value here is 0. Tangent, well, we know tangent to be sine over cosine, so that would be 1 over 0, which in this case is undefined, right? Because you can't divide by 0. Cosecant, to take reciprocals. So 1 is the same thing as saying 1 over 1, right? So the reciprocal of 1 over 1 is 1 over 1, which is still just 1. 0 is the same thing as saying 0 over 1. So the reciprocal of 0 over 1 would be 1 over 0, which is undefined. So secant of pi over 2 is not a thing. For cotangent, we know it is the reciprocal of tangent, so it would be 0 over 1, and 0 over 1 is just 0. So for cotangent there, cotangent of pi over 2 gives us just 0. And again, all I did there was I looked at these coordinates, keeping in mind that the x value was cosine and the y value was sine. Let's do another one. So B. Let's say that I had theta being equal to, I don't know, let's say 2 pi over 3. And we're asking for sine of 2 pi over 3, cosine of 2 pi over 3, tangent of 2 pi over 3, and the reciprocals of all of these. So cosecant of 2 pi over 3, secant of 2 pi over 3, and finally cotangent of 2 pi over 3. All right. So for sine of 2 pi over 3, well, we're first going to go to the angle of 2 pi over 3. And we're going to say, well, sine is the y value. Cosine is the x value. So sine is the y value, so radical 3 over 2. Cosine is the x value, so negative 1/2. Tangent is sine over cosine, so we're going to say it is radical 3 over 2 over negative 1/2. And then at that point, we're going to say, well, if I'm going to take a fraction and divide it by another fraction, that's the same thing as multiplying by the reciprocal of it, right? And we would see here that the 2's cancel each other out. So our answer is negative radical 3. All right. Now, for the rest of these, cosecant. Cosecant is a reciprocal of sine, so it would be 2 over radical 3. But we don't like that. We don't like having radicals in our denominators. So I'm going to rationalize this and write it as times radical 3 over radical 3. Remember there, all I'm doing is multiplying by 1. And multiplying by 1 does not change a thing. So what I end up with here is 2 radical 3 over 3. For secant, take the reciprocal of cosine. So the reciprocal of negative 1 over 2 ends up being just simply negative 2. And for cotangent, take the reciprocal of tangent. The reciprocal of tangent, so this is negative radical 3 over 1. So it's going to be negative 1 over radical 3. But again, we don't like radicals on the denominator. So I'm going to multiply by radical 3 over radical 3, which again just equals 1. So we're not changing anything because multiplying by 1 changes nothing. So what we're going to get here is negative radical 3 over 3. All right. So those are all of our 6 trig function values at that angle of 2 pi over 3. Let's do another one. Let's say that I had so example C. Let's say theta was actually 7 pi over 6. All right, 7 pi over 6. So in here, we're going to say, well, we're really looking for sine of 7 pi over 6, cosine of 7 pi over 6, tangent of 7 pi over 6, the reciprocals, cosecant of 7 pi over 6, secant of 7 pi over 6, and cotangent of 7 pi over 6. And let's move that a little bit. Okay. Now, in here, well, we're going to go to the coordinate that corresponds to the angle of 7 pi over 6. And that's right here. Right, 7 pi over 6. And we know the x value is cosine, the y value is sine. So y is negative 1/2. Cosine is negative radical 3 over 2. For tangent, we know it's sine over cosine. So I've got negative 1/2 over negative radical 3 over 2, which is really a fraction being divided by another fraction. We know that that's just multiplying by the reciprocal. So we have a negative times a negative is a positive. 2 and 2's reduce. So I have 1 over radical 3. But we don't like that. So I'm just going to rationalize this, and I'm going to rationalize it by multiplying by radical 3 over radical 3, which gives us our final answer of radical 3 over 3. All right, because remember, this right here is just multiplying by 1. It changes nothing. Now over here, for cosecant, let's just take the reciprocal of sine. So negative 2. For secant, the reciprocal of cosine. So negative 2 over radical 3. And I'm going to skip a step here, but I'm going to say this is just simply negative 2 radical 3 over 3. And again, that's by multiplying by radical 3 over radical 3. For cotangent of 7 pi over 6, we're going to take the reciprocal of tangent, but I'm going to take it from here. All right, so the reciprocal of 1 over radical 3 is just radical 3 over 1. You could have also said 3 over radical 3, but then you have to rationalize this, and we have 3 radical 3 over 3, but then those 3's cancel out, and you end up with just radical 3. But I would suggest you get into the habit of looking at, before that, there was an easier one that I could just take the reciprocal of without having to do extra work. All right. So that is cotangent of, that is all the 6 trig values for the angle of 7 pi over 6. Now, let's look at what if we had some negative angles. So that was C. D. What if I had theta is equal to negative 5 pi over, well, let's not do negative 5 pi over 6. Let's do negative 7 pi over 4. All right. And Well, where is negative 7 pi over 4? Now, I know that this chart over here on this side doesn't have that angle, and we did have that angle when I drew it. It's over here. Hold on, not negative 7 pi over 4. Oh no, I messed that up. Negative 5 pi over 4 is what I meant. Negative 5 pi over 4. Alright, so here we do have negative 5 pi over 4. It's at the same as 3 pi over 4. But let's say that you didn't have that and you didn't remember exactly where this falls. And you want to be able to use the unit circle for it, right? Well, how do we get to that value of 3 pi over 4? Well, all we need to do is find a coterminal angle of negative 5 pi over 4. We know how to find the coterminal angles. So the first thing we're going to say here is, well, the coterminal angle to negative 5 pi over 4 would be by adding one full rotation. So I'm going to add 2 pi. And what would that give me? Well, 2 pi was 8 pi over 4, so it's negative 5 pi over 4 plus 8 pi over 4, which gives me 3 pi over 4. And look at that. That's how we get to this angle of 3 pi over 4. And well, now that we've justified that that angle is the same as being 3 pi over 4, now we can say, well, what is sine of 3 pi over 4? Well, actually, let's do it this way. What is sine of negative 5 pi over 4? Well, it would be the equivalent of saying sine of 3 pi over 4. Similarly, for cosine of negative 5 pi over 4, it would be the same thing as saying cosine of 3 pi over 4. So far, and well, the rest becomes the same. Tangent of negative 5 pi over 4 becomes tangent of 3 pi over 4. And well, what are these values going to be? Well, for sine, well, we know sine is the x value at 3 pi over 4. So sine, excuse me, I said that wrong. Sine is the y value, and cosine is the x value. So sine is the y value, so it's going to be radical 2 over 2. And cosine is the x value, so negative radical 2 over 2. Tangent is the ratio of these. It's sine over cosine, so I'm going to have radical 2 over 2 over negative radical 2 over 2. And look at that. What we essentially have there is just a over negative a. A over negative a is just equal to negative 1. So this right here is negative 1. All right. Now, that's for sine, cosine, and tangent. For cosecant of negative 5 pi over 4, well, that's going to be the same thing as cosecant of positive 3 pi over 4. And, well, that's going to be just the reciprocal of sine. Let's just shift this down a little bit. The reciprocal of sine. So what is the reciprocal of sine? Well, we have radical 2 over 2, so that's going to be 2 over radical 2. By rationalizing this, I end up with just simply radical 2. And by that I'm saying multiply by radical 2 over radical 2. It simplifies to just being radical 2. For secant, so secant of negative 5 pi over 4 would be just simply secant of 3 pi over 4, which would be negative 2 radical over radical 2, right? I'm taking the reciprocal of this. So at that point we say, well, that's going to be just simply negative radical 2. And for cotangent of negative 5 pi over 4, which would be just simply cotangent of 3 pi over 4, we would say the reciprocal of negative 1 is just negative 1. All right. So that is how we deal with negative angles. All right. Now, what if we had angles that were beyond the unit circle, but not just in a negative way? So perhaps in a positive way, but it's beyond 2 pi. So let's say that I have theta being equal to, let's do 15 pi over 4. Let's do it over, over 4. That's fine. 15 pi over 4. In here, the very first thing I'm going to say, well, 15 pi over 4, we can figure out a coterminal angle with this, all right? 15 pi over 4, again, it is not in a unit circle because 15 pi over 4 is larger than 2 pi, all right? It is larger than 2 pi. So the question is, where is it going to fit on this? Well, we're going to find a coterminal angle. In this case, we're going to be subtracting a revolution. And when we subtract 2 pi, well, that's the same thing as saying 15 pi over 4 minus 8 pi over 4. And 15 pi over 4 minus 8 pi over 4 is just simply 7 pi over 4. All right? And look at that. That's definitely within the unit circle, right? That's right over here, 7 pi over 4. So now we can just go ahead and say, well, for the 6 trigonometric function values, sine of 15 pi over 4 is going to be just simply sine of 7 pi over 4. And from the unit circle, that's just negative radical 2 over 2. Similarly, cosine is going to be just cosine of 7 pi over 4, which is just radical 2 over 2. And again, I'm looking at this part of the unit circle, all right, into this coordinate. Tangent. Tangent of 15 pi over 4 would be just simply tangent of 7 pi over 4. So that'll be sine over cosine. Well, it's the same value except they're negatives of each other. So it's just negative 1. And similarly, well, cosecant of 15 pi over 4 would just be cosecant of 7 pi over 4, which is the reciprocal of this, which is negative 2 over radical 2, but we know that's just now negative radical 2. For secant of 15 pi over 4 would be secant of 7 pi over 4, which is simply radical 2, right? The reciprocal of 2 over radical 2 is just radical 2. And lastly, for cotangent of 15 pi over 4, that would be cotangent of 7 pi over 4, and that would be the reciprocal of negative 1, which is just negative 1. All right. So that's how we deal with angles outside of the unit circle. Now, let's talk a little bit about something called periodic functions. And essentially what I'm about to talk about, well, I can take off the unit circle from display now. All right. Now, what I'm about to talk about here is just a quick, essentially, side note so that I can just reference something later on. And we're going to talk about this definition. A definition of a periodic function. All right. Now, in here, the root word for periodic is period. All right. And there with period, what we're talking about is something that repeats, all right, over a certain period of time, or certain period of what we're going to see here is x values. So a function is periodic when there exists a positive real value c, or real number c, such that f of x plus c is equal to f of x for all x in the domain of f. All right. The smallest such value c is called the period. Of f. All right. So essentially what this is saying is that a function is periodic when it repeats itself after some value c. The smallest value of c which repeats itself, that is called a period. So let's look at a quick example. So let's say that I had the following function on the graph, right? Let's say that the function look exactly like this. Oh, let's fix that. There we go. And these are supposed to all be equal. Now in here, it is clear that the function is just repeating itself over and over and over again, right? And let's say that the coordinates here, they were 5 apart. In here, well, it would be easy to say that, well, what's repeating? Well, we can say all of this is repeating over and over and over again, right? Because if I could just cut and paste that. But that's not the period of this function. This length is not the period of this function. This is length 15. It is not the period of the function because the period, again, was the smallest value, c, in which it makes the function repeat. So even this right here would not be the period, right? Because even though I can copy and paste this over and over again, and it'll be the same, that's not the period because it's not the smallest value, which makes it repeat. In fact, this piece is the smallest value that I need, or the smallest piece that I need to copy and paste over and over again. So this distance, that is c, which is our period, and it's a period of 5. But again, technically, we can say repeats over this distance, but that would not be the period because it would not be the smallest value of c, which makes it repeat. And I mean, we can have a whole bunch of different examples, right? Like if I have a function like this, where let's say it was a step function, or that looked like this. It says that to there, and then here to there. And this just repeats itself. Right? Now in here, this is clearly periodic because it's repeating itself. The question is, what is the period? All right, well, what do we need to repeat here? Now, perhaps I'll just write some distances here. Let's say these are just 1 away. You might be thinking that the period is 1, and you'd be thinking incorrectly. All right, because in here, what we need to repeat isn't just this, right? This piece right here is not a copy of this. We need to repeat all of this. That's what needs to be copied and pasted over and over again. All right, and again, it would technically this right here. Oh, that's not what I meant to do. This piece right here technically can be copied and pasted over and over again, but that wouldn't be the smallest piece that can be copied and pasted over and over again. It would be this piece, which tells us that the period is this distance. That's a period of 2. All right. All right. So again, the idea is that the smallest piece that you need to copy and paste over again, the length of that piece is the period. All right. Now, let's talk a little bit back again about trig. Sine and cosine functions. In here, let's talk about some things about these functions. The domain for both of them is all real numbers. So negative infinity to positive infinity, right? All real numbers. The range for both of these is between -1 and +1, including both of them. All right, including -1 and +1. Now, since well, let's perhaps we'll just discuss it. If if you recall, with rotations, adding a whole rotation yielded a coterminal angle, right? So, and if we look back at the examples that I was doing before, there we go, in here, where I added a whole rotation to find a coterminal angle. Well, essentially what that tells us is that by adding one rotation, I'm back to the same value. That is the period of this function of sine. Similarly for cosine, adding one full rotation gives me that same value right there. So that would be the period of cosine. So for both sine and cosine, we've got the period being equal to 2 pi. All right. So essentially what this tells us is that sine of theta plus 2 pi is equal to just sine theta, and cosine of theta plus 2 pi is equal to just cosine of theta. All right. And again, that 2 pi is the smallest value that we need to add in order for these to start repeating themselves. All right. So, and again, what this tells us is that they're both periodic. I got right here. They're both periodic, which means they have a period, and the period happens to be 2 pi. All right, now we'll talk about the graphs of these in a different section, but let's look a little bit at the unit circle once again, but just not the entire unit circle. If I have this circle here, right, and this is on the coordinate axis, we have something like this. And perhaps we can shift this a little bit down to make it better. Look at that, way better. Looks way more centered. Good job, me. Now, if we consider this this point P here, being x comma y, right? With this angle right here being angle theta. And we consider also this point over here, Q, where this angle here is just the negative version of that. Well, the coordinate of point Q, the x value would be the same, right? Because it's just going through the same thing there. But the y value would be negative y, all right? Because in here we've got this distance up here being y, but this distance down here being negative y. Both of them have this value right here, this distance being just x. All right. Now, perhaps I'll do it this way. This distance being just x. All right. Now, why do I care about this? Well, let's consider the following. If I have cosine of negative theta, well, from here, and remember this is the unit circle, so the hypotenuse is just 1. Cosine of negative theta, well, I would go to this angle, I would look at this triangle, and I would say, well, cosine was adjacent over hypotenuse. The adjacent is still just length x. The hypotenuse is still just 1, so it's just really just x itself. Now, x itself was just simply saying cosine theta, right? If I look at this theta here, the cosine is just x value. Similarly, if I have sine of negative theta, well, sine of negative theta, if I look over here at this blue triangle, sine was opposite over hypotenuse. So opposite, negative y, over hypotenuse. The hypotenuse is 1, so it's just over 1, so that doesn't change. But y itself, by definition, if you recall, y was just sine theta. So since I have negative y, I'm going to have negative sine theta. So what does this show? Well, let me remind you of something. If I have f of negative x equals f of x, that was an even function. If I had f of negative x being negative f of x, that was an odd function. And that's exactly what's happening here. All right, cosine of negative theta is equal to cosine theta, meaning that cosine is even. Sine of negative theta is equal to negative sine theta, meaning that sine is an odd function. Now perhaps I should have put this over here. This is telling us that this one over here is even, and this one over here is odd. So let's talk about that property as far as the trig functions go. So even and odd trig functions. It turns out that there's only two even functions. The only two even functions are cosine theta and secant theta. All right. Now cosine theta, we just showed why it's even. For secant, well, let's think about that. If I have, and I'll do a quick proof on the side here. If I had secant of negative theta, that would be 1 over cosine of negative theta. But we know that cosine is even, so it would be 1 over cosine of theta, and that's just simply secant of theta. So what we showed here is that secant theta, this means secant of negative theta, is equal to just simply secant theta. So the even trig functions are cosine and secant. The rest are odd. All right, the rest are odd. So sine theta, cosecant theta, tan theta, and cotangent theta. Those are all odd. And now as far as cosecant, the proof of it looks very similar to this. So let's look at something like tangent. Why tangent is odd? Well, tan of negative theta would be sine of negative theta over cosine of negative theta. And then since we know that sine is odd from before, right? Since sine is odd, we have that sine of negative theta is just negative sine theta, and cosine of negative theta is just simply cosine theta. So now I've got the negative of sine over cosine. Sine over cosine is tangent, so I have the negative of tan theta, which means here that I've just proved that the tangent of negative theta is negative tan theta, which means it's odd. The proof for cotangent is very similar to this. All right. So the idea here is that we can use these kinds of properties to determine some values. So let's do that. What example was I at? What letter? And E, so F. All right. Example F. So let's say, so we're still evaluating. So evaluate. Let's say that I have cosine of negative 5 pi over 3. All right, and I'll bring back the unit circle. All right, cosine of negative 5 pi over 3. Well, we know that cosine is even. So because cosine is even, this is just simply cosine of 5 pi over 3. And from the unit circle, I'll go to 5 pi over 3. Where's that at? There it is, 5 pi over 3. So cosine is the x value, so it is 1/2. Now, technically, I could have found a coterminal angle to negative 5 pi over 3, and we would have gotten the same result. In fact, the coterminal angle for negative 5 pi over 3 would have been positive pi over 3, and they would have been looking at this coordinate. But in here, it's not about finding the same angle, it's about finding the same value, all right? And using the fact that cosine is even, we can just do it this way. Similarly, I can say, well, what if I have sine of negative 7 pi over, not negative 7 pi, let's do negative 5 pi over 3. Well, sine of negative 5 pi over 3, well, since sine is an odd function, that would be negative sine of 5 pi over 3. And look at that. Now we're in the unit circle. That's nice. So negative sine of 5 pi over 3. Well, again, we go to 5 pi over 3. We go to the sine value. Sine is negative radical 3 over 2. So I have the negative of negative radical 3 over 2, which is just simply positive radical 3 over 2. All right. Let's do another one. Let's say that I had something like cotangent of negative 5 pi over 6. Well, cotangent is an odd function. So we're going to say this is just simply negative cotangent of 5 pi over 6. Remember, the only even functions were cosine and its reciprocal. The rest are odd. So now that we got this negative cotangent of 5 pi over 6 from here, I can go over here to my unit circle, go to 5 pi over 6. There's 5 pi over 6. And we need negative cotangent. So cotangent was cosine over sine. So we're going to have the negative of cosine over sine. So cosine was the x value, right? So negative radical 3 over 2. And then sine 1/2. So we're going to have negative radical 3 over 2 over sine, which was 1/2. Negative times a negative is positive. Here I've got a fraction divided by another fraction, so I've got radical 3 over 2 times 2 over 1, which is just simply radical 3. All right. So keeping in mind whether this function is even or odd is definitely super helpful for getting around the unit circle. Now, let's say that I had something like this. Let's say that given that cosine of negative theta is equal to 3/10, what if I said find cosine theta? Well, cosine theta, since we know that cosine of negative theta, well, hold on, let me rephrase that. Since I know that cosine is an even function, cosine of negative theta is equal to cosine theta. But we know what cosine of negative theta is. It's 3/10. So that tells me now that cosine theta is going to be just simply 3/10. All right. Similarly, if I have, so given that sine, let me rephrase that. Given that sine of negative theta is equal to 4/5, if I said find, let's do cosecant of theta. All right. Well, what are we going to do here? Well, cosecant of theta is just 1 over sine theta. All right. So how do we use this for that? Well, let's do some side work. Since sine of negative theta is equal to negative sine theta, and then again, that's because sine is an odd function, we can say that, well, sine of negative theta was 4/5, so we can say that 4/5 is equal to negative sine theta, right? Which essentially implies that sine theta would be negative 4/5. So in here, I've got that I have here 1 over sine theta would just simply be 1 over negative 4/5. But then dividing by a fraction is multiplied by the reciprocal, and it's 1 multiplied by the reciprocal, so it's just going to be simply negative 5/4. All right. So, and again, in here, well, I used two things. I used the fact that cosecant is a reciprocal of sine, but also that sine is an odd function, and we can do this trickery with it. All right. In any case, that is the end of 4.3. 4.2. That's the end of 4.2. Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.